So if I take a look at the more quadratic modeling practice, it says that the graph at right describes the height of a bridge that stretches across a body of water. Use the graph to answer the questions below. And it asks for the maximum height of the bridge. Height makes sense as an output, as a y value. If I take a look at my vertex, or my maximum, I have a maximum height of 10 feet. If I want to know how long the bridge is, I need to know where does it start and where does it stop. It starts at 0, it stops at 20. That's a total horizontal distance of 20 feet. And then if I want to know the interval for which the bridge is sloping upwards, it looks like this is my drawing of my bridge, and I am going up from where I start all the way to my maximum. So from 0 feet all the way to 10 feet, I am increasing. So from 0 to 10 feet is the interval that I'm increasing. Again, we look at the picture, we look at the scenario, how does the graph connect to the scenario, and then we pick and choose the pieces we need. For example number 2, it says that bacteria tend to grow very fast in a petri dish at first because of the unlimited food, but then they die out because of competition. So in a certain culture, not like, like American culture, Japanese culture, Hispanic culture, African culture, or like Southeastern European culture, but culture isn't like a culture of things. I can't define it without saying the word culture. I just mean like a group of bacteria and like a city or an environment full of bacteria. The number of bacteria is given by the function n of t is equal to negative 2t squared plus 92t plus 625, where t represents the hours since 625 bacteria were introduced to the petri dish. So I know that I have a y-intercept or a starting value of 625, and I know that t is my input, or what's going to wind up being my x value when I take a look at everything on Desmos. So the first thing I want to do is I want to graph this in Desmos. So I go and type in my equation. I have my output is equal to negative 2 times my input squared plus 92 times my input plus 625. I can see I've got a pretty big graph, so I might actually change my window settings to have, let's start at 600 and 2000. So now I can see a pretty good model. Here's that initial value of 625 bacteria, and I can see that I am growing and growing and growing to a particular point, and then it starts to shrink. And so it asks, at what time will the number of bacteria reach its maximum? So that's going to be the x value, and the x value is where t is 23, or 23 hours. So after 23 hours, we will reach the maximum amount of bacteria. Now it wants the maximum number of bacteria that occur in the dish. That's going to be the y value of that same vertex or maximum point, which is 1,683 bacteria. We already remember that there were 625 bacteria originally introduced. And if you want to know how many there will be at any particular time, we go to Desmos, we click Settings, we make a table, we plug in 24 because it asks about how many bacteria there will be exactly 24 hours later, and I get an output of 1,681 bacteria after 24 hours. Nice. So again, we look at our equation, we see what important information can I actually pull out already. We graph it in Desmos. We zoom around to make sure that I can see the parts of the graph that I do care about. And then we start answering our questions. For number 3, it says that a ball is thrown upwards into the air. Its height above the ground can be modeled as a quadratic function of the time it is in the air, t. Now, which of the following is a realistic quadratic function for the scenario? So we're throwing a ball up, which means that I'm going to have a ball, and I'm going to throw it up, and it's going to fall. And that doesn't really follow that much of a parabolic arc, but this is very similar to when you guys were throwing your tennis balls on Monday. So you've got your little tennis ball, and you throw it up, and eventually it goes down. And what that means is the parabola opens down. So we cannot have answer option A or answer option B because they have a positive leading coefficient. And if you were to graph those in Desmos, you would see that the parabola would not look like what happens when you throw a ball. And then again, you're throwing the ball and you're standing on the ground. So if the ground is my x-axis, that ball is above the ground by a certain amount. So it certainly cannot be below the ground, which eliminates answer option D. So if you're throwing the ball above ground, up into the air, when you type these equations into Desmos, the only graph that makes sense is C. Feel free to plug it into Desmos yourself to see what I'm talking about.